Hello everyone and welcome to this video in which we'll be looking at the solution of a quant question from CAT 2021. So before we get into the question itself, I want to discuss a very small concept in geometry. I want to derive that concept, which is very pertinent to be used in a question of the type that I'm going to be discussing. So to understand this concept or theorem, let me first consider a triangle, let's say triangle ABC, in which the length of the three sides are taken as small a, small b, and small c, such that the length small a is opposite to capital A vertex, length small b is opposite to capital B vertex, and length small c is opposite to capital C vertex. In this triangle, let's say that we are drawing an altitude or a height from the vertex A onto BC, and I'm calling this height AD. So AD is definitely perpendicular to BC because that's the definition of a height or an altitude. And I'm taking the length of this height as h. Consequently, the point D, which is the point at which the height is meeting the side BC, I am taking the length of BD as x and the length of CD as, of course, A minus x. Now, when we have a triangle like this, then in this triangle, suppose I want to calculate the value of this angle, which is angle ABC. Or for the sake of my own convenience, I'm going to refer to this angle as cos B. I can say cos B is base my hypotenuse, which in this case is x by c. In triangle ABD, C length is the hypotenuse and the base for angle ABD will be x. So cos of angle B will be equal to x by c. Which means from this, I can say that x is equal to c times of cos B. Let's hold on to this relation. And while we're holding on to this, let me also again consider triangle ABD, in which by applying the Pythagoras theorem, we can say that c square is equal to h square plus x square. Right. Now, if I look at triangle ADC, even in triangle ADC, h is one of the sides, which means by applying the Pythagoras theorem in triangle ADC, I can write the value of h square is b square minus a minus x the whole square. So basically, I'm replacing h square as b square minus a minus x the whole square by applying the Pythagoras theorem in triangle ADC. Now, if we simplify this, then we'll get c square is equal to b square minus a square plus 2ax minus x square plus x square. So the 2x square terms will get cancelled. And I'll get, if I take all square terms to the left-hand side, I'll get a square plus c square minus b square is equal to 2ax. Now, x is nothing but c cos b, so I can replace x with c cos b, which means from this equation, we can conclude that cos b is a square plus c square minus b square by 2ac. Similar relationships can be made for cos of angle A and cos of angle C as well. So each of these angles' cosines can be represented in terms of the length of the three sides of triangle ABC. And when we do this, then these three relationships are collectively known as a cosine rule for triangles. So you can make a note of these set of relations. They are pretty important and significant because cosine rule and sine rule, which is one more rule based on trigonometry, are the two rules in which lengths of sides and measurement of angles of triangles are present together in the same equation. So cosine rule for triangles, as is mentioned in front of you, you can make a note of all of this. The only thing that you have to remember is that the length small a is opposite to capital A vertex, the length small b is opposite to capital B vertex, and length small c is opposite to capital C vertex. If you remember this, then we can apply cosine of A, cosine of B, cosine of C relations and equations to any triangle in which the sides and angles both have been given as features of the triangle. Right, keeping this in mind, let's look at the question from CAT 2021 slot 2. So the question says that ABCD be a perpendicular. The lengths of the side AD and the angle AC are 10 centimeter and 20 centimeter respectively. If the angle ADC is equal to 30 degree, then the area of the parallelogram in square centimeter is how much? So firstly, we have to draw the figure. So let me construct the parallelogram ABCD. And in this, length of AD and AC has been given as 10 and 20, and the value of angle ADC has been given to us as 30. Now we are trying to find out the area of the parallelogram ABCD. So first thing that we should try to do is somehow find the length of the other side of the parallelogram. Because opposite sides are equal, so AD and BC both will be 10 and 10. So we need to find out the length of AB or CD. So for the sake of my convenience, let me assume the length of CD to be X. Now, if we apply the cosine rule in triangle ADC, I'll get cos of angle D is equal to 10 square plus x square minus 20 square by 2 into 10 into x. The cos of angle D is cos 30 and the value of cos 30 is root 3 by 2. So from this, we'll get the relationship that 20 square and 10 square are 400 and 100 respectively. So I'll get on the right hand side x square minus 300 by 2 into 10x. 2 will get cancelled. And if we cross multiply, we'll get a quadratic equation which will say x square minus 10 root 3x minus 300 is equal to 0. So from here, we can apply the determinant formula to find out the value of x, or as it is better known, the Sridhar Acharya formula to find out the roots of the quadratic equation. So when I do that, I get minus b, which is 10 root 3, plus or minus square root of b square, which in this case is 300, minus 4ac, so minus 4 into 1 into minus 300, so that is plus 1200 by 2. And if we simplify this within the square root, I have got square root of 1500. So which means I can write that as 10 root 15 and I can take 10 common outside. So I'll get 10 into root 3 plus minus root 15. I will not consider the minus sign here because root 3 minus root 15 will be negative and length of a straight line cannot be negative. So 10 into root 3 plus 15 divided by 2. For simplifying this, I'll get this 5 into root 3 plus root 15 will be the value of x or the length of CD. Now that we know this, we can easily find out the area of the parallelogram because we know that area of the parallelogram ABCD will also be equal to twice the area of triangle ADC, because a triangle which is drawn between the same two parallel lines and on the same base as that of a parallelogram, its area will be half the area of the parallelogram, which means parallelogram ABCD's area will be twice the area of triangle ADC. Now we can find out the area of triangle ADC in multiple different ways. If you want, then you can apply the Hero's formula as well because all three side lengths are known. Or we can even apply the simple formula of half AB sine theta. Area of a triangle can be calculated as half AB sine theta, where A and B are lengths of two sides of the triangle, and theta is the angle which is present between the sides A and B. So if we apply that here, in this case, I will get area of triangle ADC as 2 into half into A into B sine theta, which in this case I can write as 10 into x, which is 5 into root 3 plus root 15 into sine 30. Now sine 30 is half. So I'll get 50 into root 3 plus root 15 by 2, which if we cancel out, we'll get the answer as 25 into root 3 plus root 15. So the answer to this question will be option C, 25 into root 3 plus root 15. That is the answer to question number 21 of CAT Slot 2 2021 paper. Thank you.